How's that?
That's great. We can see it. Thank you. You're all set to go.
Okay. All right. Good day to all of you, whatever time zone you're in. I apologize for being late this morning. It was on my calendar for 8 a.m. Pacific time, and I have a feeling my assistant scheduled uh, uh, me for the previous uh, time, which would have been 8 o'clock a.m., but when the time moved, it moved to 7 a.m. So I apologize for that, and I was actually dancing in the street. So thank you, Neil. Where many of us are very happy to hear about the results. So again, thank you, thank God for the opportunity to talk about the Earth BioGenome Project today, and congratulations to you and to your community for this inaugural meeting of the Euglena International Network. I think it's great, and just from the two talks that I've heard, I've already learned quite a bit about Euglena biology, so maybe being a little bit late wasn't so bad. So what is the Earth BioGenome Project? The Earth BioGenome Project is a confederated international network of networks that has the common and somewhat ambitious goal of sequencing and annotating the genomes of all 1.5 million known species of eukaryotes in 10 years. And for the next few minutes, I'm going to tell you about the progress in the Earth BioGenome Project in the last few years and give you some perspectives on where we're headed. You can go to the literature. In 2018, we published a perspectives piece in PNAS on the goals, the scientific goals, the opportunities, and the challenges of sequencing 1.5 million eukaryotes. And since that time, much has been done, but actually the work to get to where we are today dates back several years to the first meeting we had in 2015, actually, at the Smithsonian Institution to discuss the feasibility of sequencing all of life. That was the first discussion back in 2015. Then a meeting at the Smithsonian in 2017, which was called Biogenomics 2017. A couple of years later, joining up for the first time with the G10K Vertebrate Genomes Project Consortium, where in this particular group has been highly focused on producing high quality reference genomes. And as part of the Earth BioGenome Project, that was one of our early goals, so that we don't have to go back and sequence things again to produce reference genomes for as many of the eukaryotic families as we could get our hands on, and that I will talk a little bit more about in a few minutes. And then just most recently, last month, I hope many of you attended, we had a meeting which was hosted by the Wellcome Sanger Institute. Mark Blackster, who I know is on the call, is going to talk about Darwin Tree of Life later. This meeting was attended by more than 5,000 people in 80 countries. And it shows the really intense interest out there in the world about what is happening with the Earth BioGenome Project. And so what are our goals? If you focus here on the left side, the Earth BioGenome Project is certainly focused on trying to understand the origins and evolution of eukaryotic life on Earth. We already know the tremendous contribution that DNA sequences and DNA sequencing have had on the understanding of eukaryotic life. Our taxonomy for eukaryotic life has been completely revised, and this process will continue. As most of you know, we sit out here, and this meeting, we are here, and the Euglenozoa and the euglenids, the folks that you're interested in, are out here among the excavates. And now this whole group of unicellular eukaryotes is becoming of great interest to biologists across the world. And certainly the sequencing of unicellular eukaryotes is now possible due to the rapid advances in DNA sequencing, especially whole genome sequencing from single cells or small numbers of cells. So in addition to revising and reinvigorating our understanding of biology and evolution, a main focus of the Earth BioGenome Project is to develop the information necessary for the conservation and even regeneration of biodiversity. I don't think it's a mystery to anyone in this room that we are in the midst of a sixth mass extinction event, with extinction rates now that are surpassing at minimum 100-fold above background rates. And it has been proposed that by the end of the century, we could lose up to half of the biodiversity on Earth, with potential catastrophic consequences for ecosystems on a planetary scale. And so conservation is a major focus of many of the people who are involved in the Earth BioGenome Project. But in addition, there's strong interest in the group to provide and from funding agencies to provide new resources for the bioeconomy, new sources of genetic variation for plants and animals to improve productivity and resistance to diseases, as well as new medicines and biomaterials from nature. So just quickly here, you'd say, well, that's that's going to cost a lot of money. Well, in reality, the amount of money that it's going to cost today, due to a million-fold reduction in the cost of DNA sequencing, is actually less to sequence all known eukaryotes than the cost of sequencing the human genome in inflation-adjusted dollars from 1991. So if you did that calculation, today we're at about, this is from back in 2017, today we're approaching $6 billion in today's dollars, and EBP costs are actually going down from the estimate that we made in 2018 because of the increased efficiencies in DNA sequencing. And the return is going to be, estimate is going to be much greater to the world and to the economy if you just measure it in dollars, where the Human Genome Project was estimated at $1 trillion to the US economy alone. There have not been any good estimates yet, but one can imagine that the return of EBP will likely be many times greater than the Human Genome Project. So as I mentioned in the first slide, EBP is a confederated international network of networks, and now involving 36 institutions that have signed the memorandum of understanding in 18 different countries and 27, actually now 28 affiliated projects working on all eukaryotic taxon. These include national and regional projects and taxon-specific efforts, such as the one that you are now beginning to engage in, and now involving, we estimate, more than 5,000 scientists around the world. And the main goal of the EBP then is to provide coordination for all the activities to reduce the amount of duplication and provide a clearinghouse of information about the Earth BioGenome Project, and to develop the standards for sequencing and assembly, and to promote the standards for sequencing and assembly, for analysis, for IT and informatics, for sample handling and processing, and as I mentioned, for communications. The EBP is committed to open access and compliance. By signing the memorandum of understanding, each institution is committing to open access of data and I stress compliance with the Nagoya Protocol for benefit sharing. This is the global distribution of the 38 institutions now. It doesn't have all of them on there. A few of them are missing. But you can see we have a fairly good global distribution. And now, because of the efforts of, thank God, Ebenezer is bringing in several countries on an African initiative, we're beginning to populate some of the more important areas of the world, which have tremendous biodiversity, as well as biodiversity hotspots. So things are moving along nicely as far as getting different countries engaged, especially those countries where biodiversity is high and the threat to the biodiversity is great. These are the 28 affiliated projects that cross all of the eukaryotic taxa, and also many of the regional projects. You'll hear from Darwin Tree of Life today. I know you'll hear from Neil Hall, who's involved, and of course your project, the Euglena International Network, was signed up recently as well. So welcome to the Earth BioGenome Project. The strategies for sequencing 1.5 million genomes, we're not trying to do this all at the same time. We have a strategy which we call the phylogenomic wave, in which we will start with a representative species from each of the known eukaryotic families. There are approximately 9,300 eukaryotic families, and sequencing a representative species to reference quality in the first 3 years of the project. This we refer to as phase 1. Phase 2 of the project, years 4 through 7, involves sequencing all of the known eukaryotic representative species from all of the known eukaryotic genera, approximately 180,000 or so of those, depending on whose taxonomy you follow. And in the out years, the final years, 3 years of the project, phase 3, sequencing the remaining 1.3 or so, 1.32 million eukaryotic species as we scale up and develop the methodologies for doing this at scale. And a lot of this obviously depends on obtaining high quality specimens to obtain high quality, high molecular weight DNA for sequencing, and that is one of our great challenges. There is another strategy, which I won't talk about too much, which is what we call the Google Life strategy. Sorry?
We just got to move to wrap up.
Okay, I shall do that. And this is where we are. I think this is quite important, that today, just about everything we know in terms of genomic biology is due to a very small fraction of known organisms, sequencing of known organisms. Less than 0.4% of species have been sequenced, but as we move up the phylogenetic tree in classic Linnaean taxonomy, you can see that the numbers get better. There are still about 20% of phyla that haven't been sampled, but this is phase 1, and you can see that we have sequences for about 15%, so there's a long way to go. Importantly, this is the quality of the assemblies that we have. We have very few assemblies, less than 400 actually, that are at the quality level of the nearly 6,000 eukaryotic species that have assemblies. We have very few that are of the quality that will meet the Earth BioGenome Project standard. And this just shows that in a graphical form. But as you can see here to the right, we're beginning now to have a very rapid expansion of reference quality genomes. Just in the last year, we've got a doubling of those across the world. Many of those sequences are coming from EBP affiliated projects. And if you look at the family level, as I mentioned, we've got a long way to go, but we have now over 200 represented with reference quality genomes, and you'll hear from Mark Blackster and perhaps others at this during this meeting. Efforts just in one place at the Wellcome Tanger Institute to produce more than 2,000 reference genomes in the next couple of years. And so this is where your community is, from what I can gather. Don't be too depressed about this, but we know that what I could gather, about 3,000 taxa of euglenids, and so far, just a single species has been sequenced. It would have been on the lower left category in terms of the quality. Looks like the contig N50s are less than even kilobase. So much improvement can be made to this first reference genome that you have. And I'm sure Neil Hall and others will be telling us about efforts now to sequence more of the Euglena and Euglenids and others in the Euglenozoa phylum. And hopefully that will lead to resolution of many of the issues about relationships and lead to greater understanding of the biology of these organisms, which you're all so interested in. So thank you all very much. It's time to go out and collect organisms and get them sequenced.
Thank you very much, Harris. That's fantastic. And always nice to end on a tardigrade. I'm afraid I'm a very, very bad chair and we're overrunning a little bit. So I'm afraid we won't be able to.
Thank you.
Yeah, thank you, Mark. It was very interesting, but we have to move on.
That's okay.
So thank you. And our next speaker